This is a classic proof that's often required in geometry. I want you to notice that ABC, triangle ABC, is the triangle we're focusing on, but please notice the auxiliary lines, CD and BD. It's important that you recognize that those are going to help us here in a few minutes. Now, the triangle inequality theorem states, in case you forgot, that any two sides of a triangle added together have to be greater than the third side. So there are actually three statements of inequality that can be created from any triangle. So you see the first statement here, the second statement is here, and then we have the third statement. So what they did is they took all of the combinations and wrote them down. Now, thankfully, we only have one left to prove. So they're giving us kind of a good starting point. So we're going to go fairly directly to that because of all this stuff that they've given us before. So we have to prove, what we're looking to prove is that AC plus BC is greater than AB. Locate D on AC. So they drew this at a very specific point because they wanted BC to equal DC. So BC is equal to DC. I hope you can see that. And so the first thing we're going to state, and I know it's going to feel kind of like, what am I writing all this stuff for initially? But I hope that if you follow along, you'll be able to see that it comes together. So the first thing I want you to recognize, draw it with a red line, is that this whole line, AD, is equal to AC plus CD by the segment addition postulate. So let's start by writing that down. AC plus DC equals AD. DC by segment addition postulate. Okay, now I think that based on the information that I gave you just a moment ago, I hope that you can see that because BC and DC are congruent, that means that angle 2 and angle 1 are congruent by the isosceles triangle theorem. So angle 1 is congruent to angle 2, and we're going to give the isosceles triangle theorem as our reason for that. Now, I know it feels like we're just adding all kinds of random things together, but I want you to see that angle 2 plus angle 3 equals angle ABD. We're going to use that in a minute. So we're going to say that angle ABD is congruent to angle 2 plus angle 3. And guess what? That's by the angle addition postulate. Okay? And now, this one's a little bit more remote, but what I want you to recognize is that if these two added together equals angle ABD, or we could just call it angle B for right now, then certainly angle ABD has to be bigger than angle 2. So let's jot that down. So angle ABD is greater than angle 2. Now I hope that's just common sense for you. But that, we're going to, as our reason, we're going to put down the comparison property of inequality, which is not one that we've talked about very much at all. But it's very logical for sure. So we can also state that if angle ABD is greater than angle 2, then certainly it has to be greater than angle 1 by substitution. All we did is substituted angle 1 and angle 2 because they are congruent to one another. So if that's true, we can substitute again. We can say that AD is greater than AB. Okay? So because we knew that angle ABD, that's the yellow one here, is greater than angle 1. So that means we can say with confidence that the side opposite, side AD, is greater than side AB. See this? This angle 1, so this side opposite angle 1, and this angle ABD with the side opposite, which is AB. So we can confidently say that AD is greater than AB by, and I'm just going to say because the side opposite the bigger angle is bigger. Probably not so professional as we could get it, but you get the drift, okay? So now we can finish out by saying that, a couple things. We can say that AC plus DC is greater than AB, okay? And we got that by saying, we knew that AD is equal to this, right? So we said, all we did is we just substituted this right down here, in here. And so we said AC plus DC is greater than AB. Now, and so that was by substitution. So we just have one more step. I am running out of room, but I think we can get it in here. So the last thing we have to say is that AC plus BC is greater than AB. Now what did I do there? AC plus BC is greater than AB. And that was by substitution as well. By substitution. Because do you remember that BC and DC were congruent? So let me just show you where I got that one. BC and DC are congruent, so that came into play down here in this last line. I hope that helped.